In this example, we have two fair spinners. Each have 4 sectors numbered 1 to 4. The two spinners are spun together and the sum of the numbers indicated on each spinner is recorded. So we need to find the probability of the spinners, indicating a sum of A, exactly 5. So first we look at creating a diagram in terms of how would it look if we were attempting to find the values of the spinner being equated to 5. So we will have 1, 2, 3, 4. 1, 2, 3, 4, and we also have 1, 2, 3, 4. Now for 1, 1, we would have 2 if we added 1 and 2 is 3, 4 and 5, and then we would have here 3, 4, the combination of 2 and 1 added, so that will give us 5 and 6, and then we would have 4, 5, 6, 7, and then we would have 5, 6, 7, 8. Now for us to find the location where, so we say this spinner 1 and this is spinner 2. So we can see that the range of 5 is across here. When these values occur, that will give us 5. So for us to find the probability in this scenario, we say the probability to get 5, it will be, because if there is 4 times occurring out of 16 chance, so we can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the total spins is 16, and we can get it out of 4, so it will be 4 over 16, and that would give us a quarter probability to achieve 5. Now for part B, we need to show more than 5. So in this scenario, you can see that there are values outside of 5. So we can see probability of more than 5. So in this scenario, we can see that we have 6 values. So we have more than 5 is 6, 1, 2, 3, 4, 5, 6. So it's representing this triangle in the corner. So that will be 6 over 16 out of the total as we measured earlier, and that would give us 3 over 8. So this will be our answer for part B. In this example, the table shows the times taken in minutes for a group of students to complete a number puzzle. So the times shown in ranges, let's say 5 and 7, 7 and 9, 9 and 11, and 11, 13, and 13 and 15, and the frequencies is 6, 13, 12, 5 and 7. A student is chosen at random. Find the probability that they finished a number puzzle. As part A, we are asked to find it in under 9 minutes. So we'll start with looking at probability of finished under 9 minutes. So we will look at the cells where it is achieved under 9. So we can see in this scenario we have the 13 and the 6. So we add these two. So we have 6 plus 13. Also the total in this scenario, we add all the value of the frequency. That will give us 40. So in this scenario we would have 19 over 40. And this will be our answer for part A. For part B, we need to find the probability over 10 and a half minutes. So we can see the 10 and a half minutes, it's almost 3/4, almost 3/4 of the range 9 to 11. So we say 10 and a half minutes is lies quarter of the range 9, that mean equal to 9 and also 11. So in this, then that will tell us that it will be equivalent to the quarter will be equivalent to 12 multiplied by a quarter. So 12 is equivalent to 12 multiplied by a quarter, so that will give us equal 3. So that means the frequency of achieving 10.3 10 and a half, it will be for the range 9 and 11, it will be 3. So in this scenario we add the total below 10 and a half, so that will be 3 plus we also have above actually 10 and a half, so it will be 3 plus 5 plus 4, and that would give us in this scenario 12. And for us to find the probability, we would say more than 10.5. That would give us 12, and the total it will be 40. So it can be simplified to 3 over 10, and this will be our answer for part B. In this example, 2 coins are tossed. Find the probability of both coins showing the same outcome. So our first we'll create a diagram of how would that look like. So we'll have the coin 1 at the top and the coin 2 on this on the side. So we can see we have H representing the heads and T representing the tail. So we can see if both heads, that will be HH, head and tail TH, head and tail HT, and tail and tail, that's TT. So for us to find the probability in this scenario, we can see that the outcome will be 4, and we are looking for 2, either heads or tails. So in this scenario, it will be 2 over 4, and our answer in this scenario, the probability of getting the same is 2 scenarios out of 4. So that will give us the probability is half, or we can say almost 50%. And this is our answer for this question. In this example, 2 6-sided dice are thrown and their product X is recorded. For part A, draw a sample space diagram showing all the possible outcomes of this experiment. So in this scenario, we will start by drawing all the possible outcomes. So we can see we have 1 will give us 1, 2 will give us 2, 2 and 1 will give us 2. So it's almost finding the addition of these samples and what will they give us, and this is populated here as shown. So now for part B, we need to find the probability of each event. So for instance, X being equivalent to 24. So in this scenario, when probability of X equal to 24, we can see that we have 36 outcomes, and we can see that there is 24 in 2 scenarios here and here. So we have 2 possibilities to get 36. So that will give us 2 divided by 36. That will give us 1 over 18. The probability of achieving bigger than 5. So in this scenario, we're looking at 8 scenarios where we are getting bigger than 5. Smaller than 5 actually. So we're looking at 8 scenarios here over 36, and that will give us 2. When we simplify it, that will give us 2 over 9. For the possibility of achieving only even numbers, in this scenario we can see that we have 27 even numbers out of the 36 recorded data, and that will be divided by 36, which is the total numbers, and that can be simplified to give us 3 over 4, which will be our answer for part triple I. In this example, the masses of 140 adult bull mastiffs are recorded in the table. 1 dog is chosen at random. For part A, find the probability that the dog has a mass of 54 kilograms or more. So in this scenario, we will start by looking at probability of lower than 54, bigger and equal to 54. So we can take the values of 54, which is 33. It's the 33 frequency is still considered within the 54, and we also have 21 and 2. So we add all these values, and we can see the total of the frequency, the addition of them will equate to 140. So when we simplify, that would give us 56 over 40, which can be simplified to 2 over 5. Now, within the question, it says that the probability that a Rottweiler chosen at random has a mass under 53 kilogram is 0.54. So, and we also need to find the probability that a dog has a mass between 48 kilograms and 57 kilograms. So in this part, we can see we can take the range of between 48 and 57. So we're taking two ranges here, which will involve the 25 and the 42, and we're also taking the 54 because it could a little bit higher than the 53 kilogram that's desired. So we've taken three ranges here, which is the frequencies of 25, 42 and 33, all divided about over the 140. So that will give us 100 over 140, and that will give us 5 over 7. For part C, is it more or less likely that a bull mastiff chosen at random has a mass under 53 kilogram? State one assumption you have made in making your decision. So in this scenario, we would look at letting B the number of bull mastiffs with a mass less than 53 kilograms. So this is the assumption that we will need to make. So for us, we will use interpolation. So we're taking the ranges of 54 because we're looking at 53, and also we're looking at the range of 54, taken away from the range of 51, so which is the average range that we're looking at for both. And on the right hand side, we would have the bull mastiff, which is represented in the B as a variable, taken away from the ranges of between 48 and 51, which is the two lower ranges, which is 17 plus 25, their frequencies, all divided by the addition of these two ranges, which 25 and 17, that would give us 42. So now we will attempt to simplify this expression on both left hand side and right hand side. That would give us B being equivalent to 70. Now, in terms of finding the probability of being less than 53 kilograms, we have 70, and that will be divided over the total of the frequency, which is 140, which will equate to half. So half of the bull mastiffs are estimated to have a mass less than 53 kilograms, and this will be our answer for this question. And also we also need to explain this probability is lower than the probability of 0.54 for Rottweilers, and so it is less likely.